These are the solutions for the third practice quiz, for the fifth quiz in the first trimester. So again, you need to go through and do this calculation correctly. I'm going to go a little faster through this one. And you're going to get one of each. So this is an irrational number, meaning that simply we cannot take the square root of it. Square root of 17 is an irrational number. So that result is going to produce the two irrational solutions. Here, this is a perfect square, so when we square root it, we get rational solutions, so that's A. And then here, since it's negative, when we square root it, we'll get an I on the end, meaning it's imaginary, meaning no x-intercepts. And then here, we're going to get 1. So 1 x-intercept at the vertex there, 2 x-intercepts that are nice, no x-intercepts, and then 1 is 2 x-intercepts that are not nice at all. So 5b squared minus 4ac is 1, and then 4, so you're going to get numbers that you can easily square root on this. And then b is 5. So this will be 1, so we're doing negative 5 plus and minus 1 over 4. So we have negative 6 over 4, negative 3 halves, and then we have negative 4 over 4, which is negative 1. So these will work out. You got to crunch them out, and the square root will happen nicely. So 8 will go here, plus and minus the square root of 4 over 2 times 1. So this will be 2. So negative 8 minus 2, negative 10 over 2 is negative 5. And then negative 8 plus 2, negative 6 over 2 is negative 3. So you will get fairly nice solutions on 5 and 6. Second page is all irrational solutions, ones that will not work nicely. So So 17, when you square root that, that's not going to be nice. Plus and minus the square root of 17 over 2 times 1. So make sure you understand, I am not saying this over and over. Maybe you said a rhyme in middle school. But what is it you're doing? You are doing this formula. Just to take that time out. That calculates, from our original set of notes we had, that calculates the x-intercepts if they exist. Okay, so the square root of 17 does not reduce. So that is it. On number 8, we get 44. So 0 is b. Square root of 44 over 2 times 1. So now the square root of 44 will reduce. 2 times the square root of 11. The square root of 4 times square root of 11. So this is going to be plus and minus the square root of 11. These 2's will drop out. There's my little advertisement again. What an annoying way to try to extract money from people. Okay, number 9, 76. When you do that, okay, so b squared plus and minus the square root of that all over 2 times 2. So 76 will reduce as 2 times the square root of 19. So 4 and 19. A lot of times, if you don't know, guess 4. Sorry, I didn't mean to write squared there. If you don't know, guess 4 is the largest perfect one that would go in. So all of these will reduce by 2. The 10, the 2, and the 4 will reduce by 2. So we have negative 5 plus and minus the square root of 19 over 2. And then 10, 52 is the discriminant. And then again, just don't always assume on the bottom that that's a 1. Oftentimes it's not. So square root of 52 does reduce. Again, 4. So square root of 4 times square root of 13, which makes 2 times the square root of 13. I just write the reduction above the square root, if it happens. And so we can reduce everything by 2. So negative 4 plus and minus the square root of 13 over 3. Again, what is this? What are we doing? We are figuring out exactly the x-intercepts. And if you ran this through your polynomial 2, it would show you long decimals. And if you crunch those out on your calculator, they would be the same. Okay, third page. So now this is our imaginary page here. So b squared minus 4ac is negative 484 on this. Okay, so b is 0. So 484 reduces perfectly, but that doesn't matter because of the negative. So this reduces to 11, or I'm sorry, I think 22. Pretty sure 22. Yes. So plus and minus 22i. So write that right above it over 2. So it's plus and minus 11i. And now you have to show that by substituting this in, this is true. So you need to have these two terms. So I'm looking for the two terms that would cancel out. Remember, that's negative 1. Negative 1 times 121. So 3 plus 2i is a solution, then 3 minus 2i is. And that's what you're going to use on this to figure out the quadratic. And notice that it's just the opposite of what these two the number part of the complex number. And then the product, the FOIL product. So 9 minus 6i plus 6i minus 4i squared. I did that quick. So it'll be 9 plus 4, the negative 6i positive 6i will drop out. 9 plus 4, which is 13. So then you put these are the coefficients on the. So again, you could check this in your polynomial 2 to see that it gives you back 3 plus I, 3 minus 2i. It's something that you should do, or check it on the online calculator. All right, so factoring. Quickly, negative 7 and 7 are the roots. So we have x plus 7 times x minus 7. And there's no common factor. Negative 3/2, negative 1/2 here. So 2x plus 3, 2x plus 1. And check 2x times 2x is 4x squared. We're good. No common factor. 9, negative 9. Make sure you go opposite in here because of the way that this is formed. Because it's formed with subtraction, it's opposite, the h is. The plus k on the end means you take exactly that number. And then you can go in, 3 negative 15 is the pattern on the table. You can also do this. I'll show the other way, This is 3, and then you substitute 3 in. That's all a table does, by the way. A table is just a substitutor. It's taking whatever values of x you tell it, and it's substituting it into the equation that you give it. So 9 minus 18 is negative 9 minus 6, negative 15. That's all a table does. So you could always do that to find the vertex. Here, you're forced to use the A that formula where HK is the vertex. And so you see H is opposite of negative H. That's why you have to use the opposite in that.